Hi, I'm Dr. Christopher Sutton, and welcome back to my Introduction to GIS video series. In this set of videos, we will examine the various aspects of coordinate reference systems. In this video, I will introduce coordinate reference systems. In the subsequent videos, we will examine reference ellipsoids, the geoid, and datums. The topic of coordinate reference systems is vast and can be quite technical. It is my aim in these videos to provide foundational knowledge upon which you can build to understand the intricacies of coordinate reference systems. Coordinate reference systems define how spatial data is positioned on Earth. Knowing about coordinate reference systems is essential for ensuring accurate mapping, analysis, and integration of geographic information. A coordinate reference system is fundamental to any GIS work because it defines the position of features in either 2- or 3-dimensional space. Without a coordinate reference system, spatial data would lack context, making it impossible to analyze or visualize geographic relationships accurately. A coordinate reference system has 3 primary components. The first is a reference ellipsoid, which is a simplified, smooth mathematical shape approximating Earth's overall shape. This model is essential for mapping and geodetic calculations. The second component is the datum. A datum defines the origin, orientation, and dimensions of the ellipsoid relative to Earth's surface. It provides the coordinate system for mapping and navigation. Thus, longitude and latitude positions are derived from a datum. The third component is a projection, which is the transformation of 3-dimensional coordinate positions on Earth's surface onto a 2-dimensional plane. Because Earth is a 3-dimensional object, representing it on a flat surface inherently involves distortion. Different map projection techniques are employed to mitigate these distortions, with the choice of projection being determined by the map's intended purpose or the specific geographic area it represents. I will have a series of videos on map projections coming up later. Finally, there's the geoid, which is a model of Earth's surface as defined by its gravitational field. A geoid is not part of most coordinate reference systems, but it influences the development of datums. Why is it important to understand coordinate reference systems in GIS? There are many reasons. Let's look at a few. A coordinate reference system defines how spatial data, points, lines, and polygons, for example, are mapped to Earth's surface. Without a proper coordinate reference system, geographic features may be misaligned, incorrectly scaled, or placed in the wrong location. A basic principle in GIS is that map layers being used together must align spatially. Here we see an example of interstate highways in Illinois and Iowa using different coordinate systems. This is a bit of an exaggeration, but you see how having different coordinate systems can result in misaligned data. Here we have the interstate highways using the same coordinate system, and the positions of Iowa and Illinois are correctly aligned. GIS projects often involve combining data from multiple sources, such as satellite imagery, survey data, and maps. If the data uses different coordinate reference systems, it cannot be accurately overlaid or analyzed together without first transforming it to a common coordinate reference system. A coordinate reference system ensures that measurements are accurate and meaningful. It ensures that distances are calculated correctly, areas are measured accurately, and directions between points are meaningful. Some coordinate reference systems are optimized for specific regions or purposes, and using the wrong coordinate reference system can lead to significant measurement errors. GIS relies on spatial analysis to answer questions about geographic relationships, patterns, and measurements. Many GIS analyses, such as proximity analysis, network analysis, or spatial interpolation, rely on accurate spatial relationships. A proper coordinate reference system ensures that these relationships are correctly represented, leading to reliable results. There are different types of coordinate reference systems. There are geographic coordinate systems, or GCS, There are projected coordinate systems, or PCS, local coordinate systems, or LCS, and vertical coordinate systems. A geographic coordinate system is a global ellipsoidal or spherical coordinate system that uses latitude and longitude to define the locations of points on Earth's surface. Geographic coordinate systems are used for global positioning and are the foundation for all other coordinate systems. A coordinate system will have an origin, which is the position from which coordinates are determined. A geographic coordinate system has its origin at the intersection of the prime meridian and the equator. GCS coordinates are expressed as longitude and latitude. We use angular units for coordinates, and they are conveyed as degrees of arc from either the prime meridian or the equator. A projected coordinate system is a two-dimensional coordinate system derived from a geographic coordinate system by applying a map projection. Coordinate positions in a PCS are based on Cartesian coordinate geometry. You likely have experienced Cartesian coordinate geometry where we have an x-axis and a y-axis, and coordinate position is expressed as the distance from each of these axes. Projected coordinate systems are used for mapping, spatial analysis, and measurement in a local or regional context. Rather than longitude and latitude, coordinates frequently are expressed as linear measurements, often called eastings and northings. We use linear measurement, meaning meters or feet, to express coordinate position. There are two major projected coordinate systems used in the United States. The first being Universal Transverse Mercator, or UTM, and the other being the State Plane Coordinate System. Local coordinate systems are created for small areas and individual projects, such as indoor mapping and construction projects. The origin and orientation of the system are defined based on a local reference point, which could be the corner of a building or a survey marker. Local coordinate systems are not tied to a global datum or ellipsoid. Finally, we have vertical coordinate systems, which are used to measure elevations and depths. They are based on mean sea level or other reference surface. Coordinate reference systems provide the framework for locating geographic features on Earth's surface using coordinates. In the next video, we will examine reference ellipsoids, which are the mathematical models from which coordinates can be derived.